Hello, third years. So this is the second set of probability problems that I had given you to work on, and I'm going to go through the solutions of them now. The first question talks about a net which is folded to make a die here, and you can count it up and you can see that it will have 6 sides. Sorry for the noise. It will have 6 sides even though they're not numbered the usual 1 to 6. And so there's some work on geometry and area and volume in trying to visualize the net here as well. If we were to fold up this die, what would it look like? Well, we can imagine that these are the 2 sides, side 1 and side 2, and then if this was the top, this would be the front, this would be the bottom, and this would be the back. And visualizing that helps us to work out what number would be opposite the number 7 on the die, and hopefully you can see it will be the number 1. The die is rolled once. Find the probability that the number rolled is greater than 6. So remember, the probability of an event is the number of matching events divided by the total number of outcomes. So my total here is going to be 6. There's 6 possible outcomes, the sample space being 1, 3, 4, 7, 5, 7, 8. Okay, those are the 6 numbers that can come out. How many of those are greater than 6? There are 2 that are greater than 6, so the probability that I get a number greater than 6 is 2 out of 6, which is 1/3. And that's the answer. Okay, you could have just done this bit, I'm just explaining where it came from. The die is rolled 60 times. Work out how many times you would expect an odd number to be rolled. So this is our expected value. First of all, we need to find the probability that we get an odd value. And looking at our sample space up above here, 1, 3, 5, and 7 are all odd values. So the probability of getting an odd value is 4 out of 6, or 2/3. Then the expected value, the expected frequency is going to be 60 multiplied by that probability, 2/3 of 60, which is 40 times. Again, you don't need to write down all of those. You just need to do the calculation and show it. The following 3 terms are used when discussing experiments in probability: outcome, sample space, and event. So you remember we wrote down definitions for these. We must write the term next to the description here. The set of all possible outcomes, we know that that's our sample space. One possible result, that's an outcome, a single outcome. And a subset of the sample space, a collection of 1 or more. And I've told you it's not just 1 or more, it's 0, 1 or more. But yes, that will be an event. So an event can match 1 or 0 or more than 1 outcome. Okay. On to the next question then. A box contains red pens and blue pens. The probability that a pen picked at random from the box is red is 2/7. Write down 3 possible values for the number of red pens in the box. Okay, we don't know how many pens there are in total, but we know that it must be a multiple of 7. Why do we know that? Because when we simplify the fraction, it's going to be something out of 7. So the matching outcomes out of the total outcomes could have been 4 out of 14, or 6 out of 21, or 9 out of 20, 8 out of 28, and so on and so forth. So the number of red pens then must be multiples of 2, the top number there. So 3 possible values, 2, 4, 6. When we calculated the probability could have been 2 out of 7, or it could have been 4 out of 14, which then simplified to 2 out of 7, or it could have been 6 out of 21, which also simplified to 2 out of 7. Just explaining where that came from there. Now, find the probability that a pen picked at random from the box will be blue. So it only contains red pens and blue pens, which means that the probability of a pen being blue is 1 minus the probability that it's red, which is 5/7. That's our answer. Explain why there cannot be exactly 20 pens in total in the box. We've kind of already explained it here. The probability of having a red pen, for example, is 2 out of 7, which is the number of red pens over the total number of pens in the box. So therefore, the total must be a multiple of 7. So that's the final explanation there. And they're big in the junior cert on having you guys able to explain why things are true. You don't have to go into a lot of detail. Giving an example, giving a mathematical example will definitely get you partial, if not full credit on a lot of those. Okay, part D. Some green pens are put into the box so that 25% of the pens in the box are now green. 1 pen is picked at random from the box. Find the probability that this pen is blue. Okay. So this is a little bit complicated. 1/4 of the pens that are now in the box are green. And 3/4 of those remaining pens are either red or blue. Of those 3/4, 2/7 of those are red and 5/7 of those are blue. So we have to do some work with fractions to work with this. So the probability of having a blue pen is going to be 5/7 of the 3/4. Now, hopefully you guys all remember from primary school or first year that of means multiply. So all we need to do is multiply those fractions. You can do it the long way manually, or you can just use your calculator to do it. So into the calculator we type 5/7 multiplied by 3/4 and get our final answer there, 15 out of 28. And that's it, that's all we need to do. So the key there was realizing that the remaining 3/4, now that we'd added in the green pens, we had to find 2/7 of that for the red ones and 5/7 of that for the blue. Okay, the next question then. Pauline flips a fair coin 3 times and she records the outcomes, and we want to record all the possible outcomes. You can do it by what we call systematic listing. All heads, 1 tail, and then we need to look at the different arrangements of having exactly 1 tail, which means we move the tail position to the 3 different locations. Then what about if we had 1 head and we move the head position to the 3 different locations, and finally 3 heads all together like that. You could also use a tree diagram to get these outcomes. If you find systematic listing difficult, you could have used a tree diagram. So heads or tails, 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 and then list your outcomes. Heads, 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 tails, etc. You can see that in your notes in more detail if you want to go over that. Find the probability of getting 2 heads and 1 tail. So my total number of outcomes, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 outcomes in total. How many of those have exactly 2 heads and 1 tail? This one, and this one. So the probability of 2 heads and 1 tail in any order is 3 out of 8. And yes, it would be fine to just write that down. You don't need to show the working out. Jamie says you have the same probability of getting 3 heads as you do of getting 2 heads and 1 tail. Well, I think we can see very clearly that the probability of 2 heads and 1 tail is 3/8, while the probability of getting 3 heads in a row, well, there's only one outcome that matches that, is 1/8. So there's our explanation, and the answer is no, we don't agree with him, because the probabilities are clearly different. Max says you have the same probability of getting 3 heads as you do of getting a heads, then a tails, then a heads. And yes, I'd agree with that, because the probability of getting 3 heads is 1/8. It only matches one outcome. And the probability of getting heads, tails, and heads in this specific order only matches one outcome as well. Only matched one outcome. So those are equal. So that's equal to 1/8 as well. So yes, I would agree with Max. Sometimes it's easier to write down the reason first and then state whether you agree with them or not. Okay, that's everything that I asked you to do yesterday on probability. Again, you might go through those questions, make sure you understood them, and pause the video, go over it if you're confused on something. And if you've done that and you're still confused, then you can leave me a message in Google Classroom. Right. Thank you.